In this video, we are going to calculate the value of a series. We are given the following series. The sum from n equals 0 to infinity of a times 2 to the power of n plus 1, divided by 5 to the power of n. Now, the first thing you should consider is this. In general, there are only a few types of series where we can actually calculate the exact value. We know the value of the geometric series, we know the value of the exponential series, and perhaps also the values of the sine and cosine series. By that, I mean we know their specific formulas and what the series themselves look like. At this point, you should think, let's call it a conjecture, that it must be one of these series, because we are expected to find a specific value. The exponential series involves factorials, as do the sine and cosine series. Therefore, the idea here should be, I'll try to shape this into a geometric series somehow. And strictly speaking, that is actually quite easy. We simply have our series. The sum from n equals 0 to infinity of a times 2 to the power of n plus 1 divided by 5 to the power of n. At this stage, we can break this apart and say that this is the same as the sum from n equals 0 to infinity of a times 2 to the power of n divided by 5 to the power of n. I'll do this step by step to make it clear. Now we have a 2 and an a that do not depend on the summation index n. This means we are allowed to move these two values in front of the sum. So, what we have here is 2a times the sum of 2/5 to the power of n, with the limits of summation naturally being from 0 to infinity. And here, indeed, we have a geometric series. We know that its value is 1 divided by 1 minus z, where z in this case is this value 2/5. This means we have 2a times in parentheses 1 divided by 1 minus 2/5. Let's look at the denominator first. 1 minus 2/5 is 3/5. And 1 divided by 3/5 is basically the multiplication by the reciprocal. That means we have 2a times 5/3 equals 10/3 a. And with that, we have successfully calculated the value of this series.